All right, so why don't we get started? It's a couple minutes after the hour. That's usually enough time. So welcome everyone. You are at, as I said, at the Knowledge Transfer webinar series that ExxonMobil has been coordinating. This is webinar 4. We are recording this talk, and we will be posting the talk on an API website, and I believe information on where those recordings will be posted, so you could come back or send someone else to that website to look at. So the purpose of this webinar is to allow highly experienced oil spill response experts to describe what they believe is important, lessons they've learned over time, and allow that knowledge to be transferred to those who are less seasoned, I guess. And so we want them to share their insights and perspectives. And we're trying to get groups from various sectors, right? And we've had some folks that are consultants to industry, some long-term oil spill responders and other oil spill response experts. And we're going to continue on as long as we see that there's energy, enthusiasm for this on a monthly basis. It's going to be the first Tuesday of every month, right? At this time, which is different depending on where you are. Right. So what we've done, so this week we're going to have Ed Owens, and I'll give you a brief introduction of Ed, and probably most people on the line on the Zoom call know who Ed Owens is, but I'll give a little introduction. And he sent me a couple sentences about him, which was kind of information that I didn't know about, which is kind of interesting. So what we're going to do is we're going to allow Ed to speak for about an hour or so, and then we've logged this, or we booked this webinar for an hour and 15 minutes. But in the past, what we've done is allow additional questions. There's usually more questions than can be answered in 15 minutes. And so Ed has graciously agreed to stay on until we get questions answered. It usually takes about another 15 minutes. So if you want to stay beyond the hour and 15, we'll try to answer as many questions as possible. And we usually end up with stopping the webinar at and half past the hour, so an hour and a half. You'll see so the webinar is set up so we have the panelists and then participants. And so if you hear me, you're probably a participant. And the way you can ask questions is there's a Q&A button at the bottom of the Zoom panel, right? And so as Ed is speaking, go ahead and start asking questions, and we'll see those questions as they come up, and at the end we'll go through the list of questions, right? Okay, so I think I got everything as far as the background and how we're going to run the meeting. So let me introduce Ed and then turn it over to Ed. So Ed Owens was seconded to the Aero Response Operations in Nova Scotia back in 1970 because he knew something about shorelines, although nothing about oil spills. He spent the next 10 years as a government university research scientist trying to avoid oil spills, to no avail. Eventually, in 1979, he succumbed to the world of consultants and has been involved full-time since then with preparedness training research, as well as responding to oil spills worldwide. His focus is on innovation for coastal oil spills and to continually improve shoreline response programs by adapting lessons learned to the decision process and operational practices. He pioneered aerial videotape mapping techniques in the early 1980s, which evolved during the 1989 Prince William Sound response. That's the ExxonMobil politically correct way of saying the Exxon Valdez oil spill. So he pioneered that and turned it into a shoreline survey strategy that's today known as SCAT. Currently, among other things, he is actively evaluating the applications of canine detection dogs for shoreline and pipeline response, and the analysis of drone imagery to support shoreline surveys. I've known Ed for a long time, and he is an excellent speaker, so I'm really looking forward to this talk. So Ed, I'm turning it over to you. Thank you.
Oh, thank you very much, Tim, and hello, everybody. I'm sure I know quite a few of you out there and would like to see you again sometime soon. But one of the primary purposes for this webinar, as Tim says, is for those who are working their way in the profession and learning, and not in the way we used to learn, which is very often face-to-face, at meetings and conferences and seminars, technical workshops, etc. Things have changed a little bit. They'll come back together, but for now, I think this is an excellent way in which we, I like the word seasoned practitioners, have been given this opportunity to pass on some of the things that we think are important, both in the past and present. And how did we get to this point, and where are we going to go from now? Had a couple of hard acts to follow there with Al and Ann Hayward and Steve. Al was kind enough to give me a call yesterday to wish me well, and just made me a bit more nervous probably than I'm meant to be. So, but I think I'm going to take a leaf out of Al's book and start at the beginning. Where did all this start? And at the end, try and answer the questions: what do we really do when an oil hits the shorelines, and why is it seemingly often so complex when it should be something we think professionally is not that difficult? Well, to begin at the beginning, I came to North America. You maybe tell I got a bit of an accent left, but within 10 days of being over this side of the pond, I was working on a student research program at 75 degrees north, looking at Arctic beaches. And when I'd finished that, I'd had enough of school, and I went and got a job. And I worked for the Canadian Hydrographic Service in Ottawa, federal government there. And I was making bathymetric maps. These are different from navigation charts, and it's really a nice job. I enjoyed it, but I hadn't been there very long when the good ship Arrow, which was, we called those things in those days leaky Greekies. It was an unseaworthy, literally, Greek tanker with a cargo of bunker C. It didn't have a working radar, and it stopped suddenly, as it says, in the middle of Chedabucto Bay and sank. And working in Ottawa at the center of power in Canada, my boss said, well, you know something about beaches. Why don't you see if you can go and help them? But, and as Tim just said, I know a little bit about beaches. I didn't know a thing about oil. And so I went down to Chedabucto Bay. And if you think ICS is new, it is new in concept, but we managed, or the spill was managed in a manner very similar to the way we work today. The three key people here are Dr. Patrick McTaggart-Cowan, who is in charge of Operation Oil, and he was assisted by Dr. Charles Sheffer from the Defense Research Board and Captain Martin from the Navy, who was the commander of the Atlantic Fleet. I think it was either Atlantic or the Pacific. There's only two to choose from. And these three gentlemen were the spill managers, the unified command, if you want. Operations was Captain Mike Greenham from Coast Guard, yours truly sitting right there. I used to dye my hair in those days, but I gave up. Finance was over here, and a couple of other people. This was the entire team that ran the spill. One person who's missing is the operations manager from the Department of Public Works. So essentially this spill was run by government people, backed up by scientists from Bedford Institute of Oceanography, which is just down the road in Nova Scotia. The spill covered a lot of Chedabucto Bay, bunker C, as I said, very dark, very heavy oil. And the first thing that people started to do, well, actually, as you can see there, top left, in June, we did a mapping survey of the entire area, so we would know where the oil was. And most of it was to the north of the spill site. This is Cerberus Rock, where the Arrows stopped. The inclination from the Department of Public Works was just pick it up as quickly as possible and get rid of it. And so a lot of the first work was done by mechanical removal. See here, just using a front end loader going in and actually digging underneath, and ended up scooping out somewhere between half a meter, in some cases a meter, of sediment, not all of which of course was oil. So like my first job in here was like, I am a geologist. I'm a beach guy. I do know a little bit about beaches in those days. I said, well, you know, we don't really want to take the beach away. We just want to skim the surface, you know, as thin a layer as possible from the surface. And so the guy got out of his machine and went over to talk to the boss. His name was Colin McDonald, still remember. And he said, well, this is my best operator. He can move a lot of dirt really quickly. I said, well, we don't want to move a lot of dirt, really. We want to just skim the oil layer off the top. He said, well, you know, I bid this job on time and materials. Now you're asking me to go slow. It's going to take me a lot more time to do it. So it was renegotiated. And after that, then the operator, very good operator, was skimming just the surface. But first spill, first week or two, using a bit of science to try and minimize the amount of unoiled sediment that was being taken from those beaches, because a lot of these beaches don't replace naturally very quickly. They're relic beaches, we call them. They're derived from glacial sediments. They're derived from a source that may no longer be there. So they're not going to get replaced naturally, or if at all, very slowly. And so I started running beach profiles very quickly. Being a beach person, I knew that if you know the cross section, then you have some idea of what the changes are that are taking place. And the shaded area, this is very old. I'm not a very good draftsman, but I managed to draw these in those days. And you can see the area in the vertical hash. This is the area that was removed. And the beach profile 1 year later, the actual crest of the beach had moved inland some 20 to 30 meters. This is erosion, this is retreat. And so one of my jobs was to work with the Department of Public Works folks, and to minimize the amount of unoiled sediment that was removed from those beaches. One of the sites in, let me go back a slide. Just down in the bottom here, there's a little cove, which is called Black Duck Cove. It wasn't initially oiled, but a sort of a rogue slick came in. We don't know when exactly. It was first observed in early April, and the oil had been at sea. The spill was in February, so it had been at sea for a month or two, very weathered, and coated the entire sand and pebble cobble boulder beach of Black Duck Cove, which has become interesting now because it was never treated, never cleaned. Well, a little bit of some cottages here, a little bit was cleaned, but by and large, this area, the Black Duck Lagoon, was never treated because there was no requirement, there was no pressure to clean it. And as a result, it's become a fairly important long-term site to look at the oil persistence. And this is just a list of the dates that various people, most of these are visits that I personally have made to the site. 21, well, we were meant to be there in October of this year, but COVID restrictions being as they are, we haven't made it. So looking to go back in 2022. The outer boulder beach is interesting. There's a rock here, this rock, which is visible in all of these photographs. But this boulder beach, you can see the size of these boulders, they're about 1 meter diameter, very well rounded. And what we have found, we were digging in the top of this beach, and if you can get down about a meter, there's an oil layer, which is right within the beach sediments. The last time it was uncovered, there was hurricane winds had raised the water levels tremendously on this coast, and went down there with as part of an ExxonMobil program to look at the persistence of stranded oil on different beaches. And that layer actually had been exhumed, and some of these, you can see the color of the sediments, they're actually pretty white. Some of those oiled sediments had been thrown over the top of the berm and moved about 15 to 20 meters by that high water level event. But it's not just the outer beach, but we're looking at the weathering, attenuation, biological. Ken Lee and Roger Prince have been involved in these studies, looking at what has happened in the lagoon, look at what has happened to the weathering of the oil in the lagoon. So it's a great long-term study site. I'm just going to digress a little bit here from the history part, because if I had my wishes, there are three sites I'd take people to. One is Black Duck Cove, the Arrow spill. The other is a site down in Tierra del Fuego in the Strait of Magellan in Chile, where a cargo of light Arabian crude on the VLCC Metula coated the shoreline. These are pictures actually filched from one of Eric Gundlach's papers. Eric and Miles Hayes were down there in '74 looking at this oil spill, again, coastal people, and documenting it. And you can see again, the number of site visits that have been made to this area give it a good history. There's a great record of how changes have taken place over time. I was there in '77, '87, '98, and 2005. So I'm actually looking for a ticket to go back to see what's happened since then. One of the things that's important, Jenny Baker, a very well-known oil spill scientist, had set up some plots in 1993, some of which were left for natural attenuation, others were mixed, others were fertilized. And you can see the plots here, the stake plots, and this is just data from '98 to 2005. We were counting the plants to look at recovery. So again, this is a great site for long-term data. And the third place is northern Baffin Island, where I'll talk a bit about again in a minute. An Environment Canada oil spill experiment took place in 1980. And again, many people have been going back and forth over the years. Again, been up there with Roger Prince, Gary Sergi, and a team from National Research Council in Canada was up there most recently in 2019. So all of these three sites have persistent oil. They're anomalous because oil doesn't usually last that long. So don't want to give the impression that there's oil sitting out there all over the world. It isn't. These are special sites because they're few among the very few where we have long-term persistence data. It's all been written up. I mean, there's dozens of papers been written on each of these three incidents. So there's a great record if you're interested in the literature to go and look at it. To sort of continue historically, Environment Canada was created in 1971, not specifically as a result of the Arrow incident, but the Arrow incident certainly nudged the process along. Interestingly enough, US EPA was formed almost about the same time, within a few months of each other. And as Al was talking about the Santa Barbara blowout, that was again one of the things, an incident that nudged the federal government to set up a specific environmental agency. I got involved. I actually had a real job. I was teaching in university. I was down at LSU, in the Coastal Studies Institute there, pursuing what I thought was going to be my profession for the rest of my life. And I got cajoled to come back to Canada in September 1970 to teach a course on shoreline response. Well, I sort of cobbled together what I knew, which was really not an awful lot, basically the Arrow experience. But in teaching, it became, as I was planning it, it became clear that, like, how do you introduce shorelines to people? So develop some checklists that people could use to go to a shoreline, look at what are the different parts of the intertidal zone, what are the different sediments. We didn't use the word segments in those days, but basically, how do you build a picture of the shoreline? And that's what these checklists were used for, which really in the long run became sort of a type of SCAT form. So you can see bottom right, this is a big class. Wow. It's hard to teach a lot of people, but sometimes it really is good to have a large class. Of course, the converse is if you had a small class, you wouldn't need a big bus. But if you've got a big bus and you've got a lot of people and it gets stuck, then that's one way to get out of there. Touching on Environment Canada for a minute, I do want to give them a really strong plug because they have been a long-term sponsor of oil spill R&D. I mean, not just them. I mean, BP have a long history of supporting oil spill R&D, as does ExxonMobil and EPA. I mean, they're not alone in this, and NOAA. But I don't know, people don't seem to know about a couple of the things that really I think are quite important in respect to shoreline studies. And these were the Baffin Island oil spill experiment in 1980, where oil was released on the left-hand side there, allowed to strand and deposit on the beach and to weather or attenuate naturally. And we've been watching that, as I say, ever since, taking samples, mapping the oil distribution. The second experiment, which was also a very large multidisciplinary one, was the in-situ treatment of oiled sediment shorelines, ITOS for short. And that was held up in northern Norway in Svalbard in 1997. It was designed and managed by Environment Canada, but we had Norwegian Coastal Administration, Swedish Coast Guard Safety, we had people from UK, we had Alaska Clean Seas, ExxonMobil. I'm trying to remember everybody else who was there, but again, an international team. Again, Roger Prince, who shows up by invitation, he's a nice guy, shows up at all of these things because he is very interested in the biodegradation and the weathering of stranded oil. The Svalbard one, Ken Lee was in charge of the toxicology and the sampling associated with the work that we did there, which was testing shoreline treatment methods. And the BIOS one, we had plots where we did mixing, we used solidifiers, dispersants, and washing agents. We had some plots in a different bay than the one that's in the screen there. So there was a double thrust there of natural attenuation as well as evaluating treatment methods. The Svalbard experiment was really looking at the mixing and tilling, sediment relocation, and bioremediation as techniques. And you can see it's a very low energy wave environment. There's a lot more I could say about these, but again, they're well written up, and I would recommend, if you're interested, there's a couple of nice review papers that talk about both of these. But they were milestones because we were able to learn under controlled conditions more about the fate and behavior of the oil and the efficacy of the treatment methods. Switching gears, talk about Woodward Clyde Consultants. Back in the day in the 70s, a chap who became my long-term mentor, Jim Sada, was an environmental manager for Woodward Clyde Consultants, and they hired me in 1979 because they had been doing a lot of oil spill work. In fact, one of the first spill response manuals was published in 1979 by the EPA. This is my copy. It's a bit worn. It's actually got oil on it, so it shows it was used a little bit. This was written by, well, the project manager was Jim Sada, but Bob Castle and Carl Foggett and another young chap called Marty Kramer, you may have heard of him, were the authors of this document. And it's like a lot of things. If you look at the diagrams in there, you still see them today in the current manuals, the more up-to-date manuals. They've just been redrawn. That was written before I joined Woody Clyde. The first time I met them was in a field experiment here in the Arthur Kill in New Jersey. I think it was 1975, where oil was spilled with this EPA funded. Oil was spilled in a marsh, and a couple of different techniques were used to try and treat that oil. Because the joke was in those days that most of the boom was to keep the oil that was around the Arthur Kill from contaminating our experimental sites rather than containing the stuff that we spilled. So it's cleaned up a bit since then. But Woodward Clyde was an important group. They had an oil spill team of, as I said, Bob Castle, Marty Kramer, Carl Foggett, and a few others. John Harper was there for a while. So, and we were actively involved in oil spills and oil spill research. And so in 1989, as the famous Prince William Sound oil spill, as it is politely called, happened, Woodward Clyde was hired by the Exxon team to do shoreline surveys, what eventually became the SCAT program. And we had at the beginning in 1989, 8 rotating teams run by the Exxon program. In those days, there was no unified command. NOAA and ADEC had their own programs, and we sort of ran into each other from time to time, but there were definitely 2 or 3 distinct data sets that were being generated. It was an interesting time for many, many reasons, but we had paper maps. There'd been a very large earthquake in '64, and so the southern part of Prince William Sound had been uplifted by on the order of 30 feet, 10 meters. So what was subtidal became supratidal. The northern end of the sound was depressed about 10 feet, 3 meters. And so islands became peninsulas, or in other areas, peninsulas became islands. The maps were out of date, and that was pretty hard to work with. And so we almost had to redraw the maps as the surveys were going along. In '89, surveyed over 9,000 kilometers of shoreline. The spill up in the top right, if you can see my cursor, that's Prince William Sound. And the oil carried down, this is day 7, 11, 14, 38, 50. It carried right down into the area around Shelikof Strait and Kodiak Island. And all of this was surveyed by aerial videotape methodology. The ground work in '89, the ground teams covered over 5,500 kilometers. That's a lot of SCAT work. I'll talk again in a minute, but one of the things that sort of really came together, there was a convergence. I mentioned the checklists that we had been using for about 10 years or so as part of a training program. And with a young chap called Doug Reimer, we had done a lot of mapping of shorelines by videotaping as the data collection tool to map the character of shorelines. It started off in British Columbia, actually in 1979, and by about 1989, we had videotaped some tens of thousands of shorelines in different parts of the world as part of spill response planning, largely. So the convergence in 1989 was taking the checklists and taking the video mapping techniques that we had developed, and these really converged into what became then known as the SCAT program, of mapping oil shoreline, the shoreline character, the staging areas, et cetera, et cetera. After 1989, things changed a bit. The surveys from 1990 onwards were joint surveys that involved the state and federal agencies, and they become the different acronyms: FAST, SCAT, ASAP, MESAP. I always liked FinSAP. It was the final shoreline assessment program. Of course, it wasn't. There had to be a post-SAP because it wasn't the last one. But you can see we had a number of different survey programs. Looking back, it's hard to imagine, actually, whatever, 30 years ago, no internet, no email, no GPS, no Google Earth, no cell phones. We managed to persuade the client to buy a laptop computer, which then we had to buy an external hard drive and then another, and dozens of external hard drives. When the data from the field, because the field teams were spread out, often on boats, the field data was sent in every day by a fax machine, through a fax machine. So about 4 in the afternoon, you sort of knew you could start hitting, and these fax machines were stacked on top of each other. You start hearing the fax machines whirring, and that was when the data started coming in, and that's when we started doing all the processing. But handheld forms, handheld telephones, obviously, as well. The primary challenge in all of this is really management and organization. You know, it was pre-ICS, and on the right is the sort of the process for the shoreline program. There was an interagency shoreline cleanup committee. I think there was sometimes like 20 to 30 different representatives or stakeholders on that committee who defined priority areas. The Exxon teams did the surveys. From that, really what we now call shoreline treatment recommendations were the cleanup plans and recommendations that were developed as a result of that data. Section 108, Section 106 reviews by the State Historical Preservations Officer. These were reviewed, sent off to the FOSC, Coast Guard. Again, advice provided by the Shoreline Cleanup Committee, and these then became the work plan. So the process really in 1989 was not a lot different from what we have today. This is it's a great picture in a way, a bit of history. Dave Kennedy, still around doing the Arctic program for the federal government. Dr. Jackie Michelle, this is 4-star Admiral Yost, the commandant of the Coast Guard, who was the instant commander, FOSC at the time. Yours truly, and I'm not sure the gentleman who was there. But I mean, I mentioned we had 3 different programs. We had the Exxon SCAT team program. We had the NOAA Field Survey Shoreline Assessment Program, of which Jackie was a big part, and we had the state program, which was being led by Eric Gundlach, who is this good-looking young chap over here. And there's a connection. The connection is Miles Hayes, because Miles was professor of geology and taught coastal processes and coastal geomorphology at the University of South Carolina. And that's where I was doing my PhD. And each of the 3 of us, Eric was about a year after myself, and then Jackie a year or so after that, but all 3 of us were Miles's students. So if you want to talk about the Exxon Valdez shoreline surveys, the underlying theme is that it was run by Miles's people that Miles had trained. The one thing I learned really, well, I learned a lot from Miles, but really early on, one of the projects that I had been doing was mapping the Gulf of St. Lawrence in Canada, some thousands of kilometers of shoreline. And one of the things that Miles taught me and others was scaling. I mean, at the same time as you're looking at the details of a beach, maybe a beach profiling survey, at the same time as you're looking at a single transect, a single set of processes on a single beach, you also need to understand the system, the large scale. So we need to be working from the micro scale to the macro scale, from the pebbles, from the sands, to the attenuation of oil on a beach, to the big picture of what's happening over the hill a month from now, 3 months from now. And that served us so well on Exxon Valdez, which, as I said, I mean, we did 5,500 kilometers on the ground. So putting that picture together with the combination of what, you know, Miles's multi-scale approach, along with the checklist and the video mapping, again, there was a convergence of things that made that a successful program. If our problems in the SCAT surveys were about management and organization, operations was even grander. You know, the numbers, these are just round figures, but basically the round figures, there were 10,000 people on the response in a remote area. So they had to be housed and fed. All the life support systems were on the water, 8 task forces. So 1,000 vessels of various shapes, sizes. I'm not sure if that's the USS Juno or the Cleveland in the top left, but it's an amphibious support boat that housed, I use the word housed very loosely, more like sardine, 800 people on board of that one ship, and 100 aircraft. We had air traffic control. A couple of near misses in the early days taught us very quickly that we needed to manage air traffic very carefully. The next spill, a couple of 3 years later, oh, same cast of characters almost. There's Eddie and there's Jackie. There's Jackie, Eddie taking the picture. But we had buried oil here. You can see this layer of oiled sand over clean sand. So we had to figure out what to do with that. And the technique, we'd used this same technique on Exxon Valdez. It was called surf washing, which is a bit of a misnomer, because if you look at, this is not surf. I mean, I think of surf as something you can ride on a longboard. These are just little waves, but the term surf washing was the one that stuck initially. But on the beach, looking at the issue, talking about it with the Federal On-Scene commander here, then talking with ops about it, and eventually figuring out what to do. This is the post cleanup picture. But so what we did was actually, after the bulk oil removal, we moved the sediment down into the water. We'd had some experience on this from Exxon Valdez and some lab experiments that Jim Bragg with Exxon had conducted. And what we were looking at, this foam in here, which you can see, this foam actually are small particles of oil and clay. These mineral fines attach themselves to the outside of the particles of clay and cause it to break up. And this important thing about this is that it makes it very bioavailable. It accelerates biodegradation immensely quickly. And so it's not just pushing oil into the water, it's creating these aggregates, these agglomerates in some cases, which you can see here in one micro photograph. And this one that Michel Bouffardel took recently, a year or so ago. It's a three-dimensional picture of what one of these clay, these colloidal oil emulsion aggregates looks like. Since then, others have looked at this in more general. I'm going to talk about this a bit later on, but this is really important. How does oil behave when we intervene, or how does it behave in the first place? And what are the changes that are affected when we intervene? And a couple of good review papers, which again, I'll talk about a little bit later on, that I've tried to put this, well, not tried, I've put this, the general picture into a very clear perspective now. Sediment relocation, I've always been a great fan of this because working in Canada quite a bit in remote areas in the world, in situ treatment where we don't generate a lot of waste becomes a critical parameter in the trade-off consideration. And this is on the Selendang Ayu up in the Aleutians, which is quite remote. Working there with Gary Shiganaka looking over my shoulder. I think he's one of these young folks up in here, but taking the oil sediment and putting it down into the lower intertidal zone. And the picture on the right here shows the before and after. We're breaking down the oil, actually covering some of the oil sediments with fines that are already present in the beach, and then those get winnowed out and floated away, hopefully on the next tide. Selendang Ayu was a bit of a landmark in a way. It was a great spill because it was so far away, we were the only people there. We knew the ship was in trouble, and so we were there ahead of time, had it all set up by the time that the oil was released. And by now we had laptops, we had GPSs, satellite images, digital photography. You know, we had some really good tools, and we could use them. And this is, I think, Steve Lehman's responsible for this. Steve was on one of the SCAT teams, and rather than having those sketches, we could now take an aerial image from the helicopter, which is how we got to the sites, and a ground photo, so we could show, once we'd done the shoreline treatment recommendation, we could show operations exactly where we wanted them to go and what we wanted them to do. This is one of the SCAT teams working. There's an unusual member here, a lot of feral sheep in the area, and they must have been pretty darn bored because they just wanted to know what's going on. I mean, they hadn't seen people, so what are they doing down here? Anyway, that's one of my favorite SCAT team photographs. Command post, fairly small. Randy Henry sitting here, he was operations. Environmental unit was here. Planning, that's it. That's planning, and that's the FOSC. And it was all done in the Grand Aleutian Hotel, so the bar was just around the corner. Let's jump a bit now to another important incident, Deepwater Horizon. I was up in Alaska teaching and had to get out of there. So the interesting thing was, looking back, out of the next 32 weeks, I was on site 22. And that's something you need to be ready for. You need to be ready to stay there for a long time on an incident of this nature. And in between, I looked at my diary. In between, during those 10 weeks off, so to speak, I'd had trips to Canada, Norway, Panama, Finland, Hawaii. I mean, it wasn't like I just sat at home doing nothing in those intervening periods. But again, we had time to get ready. Because of the scale, again, this is very parallel in some ways to Prince William Sound. We had 20 interagency teams. And we weren't the only one doing surveys. For example, the NRDA rapid assessment teams are out there, the RACs. In terms of what we did over 10,000 kilometers of shoreline were flown in Louisiana alone. The ground surveys, 9,500. Interestingly enough, 78% of the shorelines were not oiled, no observed oil. I'll come back to that later. And oiled wetlands constituted about half of the oiled shoreline. So the blue here is no observed oil. Again, Bay Jimmy's up in this area. This was one of the hotspots of the oil marshes. But a tremendous amount of work went into finding the oil and documenting the oil. This is just the flight tracks for a 2-month period in Louisiana. And as you can see, I mean, 1 month, over 50,000 miles of shoreline were flown just in the immediate aftermath of the first oil coming ashore. It's going slow here. Again, the primary challenge, just as Prince William Sound, was organization and management. Actually, it was less of a challenge because the infrastructure was there. In Alaska, everything had to be done by plane or boat. At least we could drive around in Louisiana, Mississippi, Alabama, and Florida. One of the things that happened, though, because of the scale of the problem was we had a very distinct event in a communications breakdown in August of 2010 between the Louisiana Incident Command Post and the operations at one of the major operational centers in Hopedale. The communication lines just got stretched too thin, and it became a problem. They didn't get the support that they needed, and we felt that they weren't doing the things that we wanted them to do because of this lack of direct communication. So Richard Santner, BP, came up with the idea of adding a layer in between the command post and the SCAT field teams and operations. That became known as the SCAT operations liaison, SCAT ops liaison, and it is direct link to support the field people. And it's a vital two-way function. Not only do they get to understand what we want from the command post, but we get feedback on how things are going out in the field. The scale of the thing, we had rolling treatment targets. We had 3 phases in 2010 alone, and started more phases in stage 4, which is 2011. It went on into 2013. The STRs, the shoreline treatment recommendations, which we sort of honed, polished up in the Salandang Ayu, these started to become a little bigger. We have the STR, we had a 37-item breast management practice checklist, we had a section 106. By the time we finished, got 7 pages of these STRs. So these get approved, all the red circles there are where somebody's added their signature. So operations in the field suddenly get this 7 pages. Now, what does it all mean? And this is where SCAT Ops Liaison became very critical. Taking this advice, guidance, best practices, and explaining to the operations teams in the field, the supervisors and the managers, both in the local operations center and out on the beaches, on the shorelines. What does all this mean? And how can we work together to make sure that the objectives that have been set in the command post are actually fulfilled properly? So that became a huge task. Right now in Southern California, on the spill that's taking place there, the STRs are 3 pages. Hey, 3 pages is still a lot of stuff. And so again, SCAT Ops Liaison is a tool that's being used on all spills now to make sure that the wishes and the guidance from the command post are passed on to the field. So what have we learned? What have we learned? We've learned a lot. Strategically, setting up a shoreline response program, getting it right from the start. Excuse me. Again, that's a Richard Santner phrase. This ensures that the process, we're looking at it strategically, that we know where we're going. We know where the end point, the closure is going to come. So very important to understand that a shoreline program is an integrated program of many facets. We've learned the need for SCAT Ops liaison, both in the command post, talking to the operations in the command post, but more importantly in the field. The other couple of other things that have happened lately, we've now got these little handheld things with apps. We've got SCAT apps that can collect data, document data much more efficiently, primarily because they reduce the data management, the data handling. We don't have to fill out forms and then go back and redo them, etc., and get them checked. We still do the checking, of course, because we're generating a database, but they are more efficient than the old paper methods. We use small unmanned aerial systems for aerial surveys, and talk a little bit about oil detection dogs. Let's try to make a real pitch on this, because drones and dogs are, well, they're sort of, you know, people like them. They like the idea, oh, we're playing with a drone, or we've got dogs, but they're not toys. These are tools. These are tools which we need to understand how to use properly. There's all sorts of drones. I've done quite a bit of work with Chevron, looking at the bottom there at targets and the efficiency of target recognition, the accuracy of target recognition. The one thing I'll say about drones is that you can collect a tremendous amount of data. That in itself is a problem, because you got to process the data as well. Our experience, Doug Ryman and myself, of all the mapping that we've done over the years, we usually use a factor of 3 or 4 to 1. For every hour of videotape or imagery that you collect, it takes between 3 and 4 hours to process that data and to map the information. Well, blimey, you know, you go out and you do 8 hours of drone surveys, there's a lot of processing time. We need to think, I believe, at least from a shoreline assessment viewpoint, we need to do real-time interpretation. We need to have the operators, not the pilots, but the operators or the SCAT teams that are working with the drone pilots. We need to do that interpretation real time. Otherwise, we end up with scads of data we never use, and a lot of that data becomes out of out of date within another day or two as the tides and waves move all around. So I would just offer a word of caution. Don't keep flying drones and collecting data. Have a very specific purpose and turn that data around real time. Dogs. Well, dogs, and dogs. Lots of dogs. We've been using them since 2015. First introduced by Per-Johan Brandvik from Sintef. And we picked the idea and have had a number of API funded and other projects funded, working on shorelines. Did a spill in Saskatchewan. Can't remember exactly how many dog days we had, but we had 4 dog teams working for 4 months, looking for the oil. This is a dog track line with a GPS on the dog collar. This is a lab carousel where we do some internal testing. Paul Bunker, who's the dog whisperer, so to speak, he trains the dogs, the detection dogs. Working here, Elliot Taylor, who's they're putting down a 5-meter pipe, 5 meters, and the target is at the bottom of this, including tar balls and bunker C. Heavy and weathered oils, dogs got it all right. They can find stuff like that with no problem whatsoever. So they keep proving themselves from time to time. This is a new dog, or new about a year, that Paul's had, called Poppy, Springer Spaniel. And one of the tests that Paul's been doing this year, this is a submerged lake bed headspace gas delivery system. And Poppy here is directing Paul to go to that source. So we're now looking at detection of submerged and sunken oil. A lot of uses for dogs. You know, the thing that I think most useful, when we look at what the surveys do, remember I talked about Deepwater Horizon, all that blue. Well, 75% of all the shorelines that were surveyed on Deepwater Horizon had no observed oil. Exxon Valdez, 60% had no observed oil. Salindang out in the Aleutians, almost 50%. Dogs can clear areas very effectively and very efficiently, so that these no oil observed areas can be dealt with without using the more experienced, seasoned SCAT team leads. We need a SCAT assistant or somebody who does understand SCAT, but the dog's doing the work to clear the areas. Dogs are great at subsurface oil as well. Let's say just down here, 5 meters down. Pits. Well, a good SCAT team can knock out, I don't know how many pits a day, maybe 20, 50. If you've got a real slave driver, maybe even 100 a day on a sand beach, maybe just a handful on a pebble cobble beach. Deepwater Horizon, about 200,000 pits were dug in 2010 to 2012 alone. Another 50,000 pits were dug in 2013, and only a fraction of those had oil. Again, a dog can identify subsurface oil and then allow the SCAT teams to go in and dig or trench to document what is down there. So these, if used carefully for clearance or for detecting subsurface oils, dogs can be a real game changer in our SCAT survey programs. I just want to sort of finish up, well, finish the last topic is, like, we have so many manuals these days. We got manuals written for different countries. These are just all shoreline manuals. We've got SCAT manuals. Oh, every country's almost got their own, well, large countries have got their own SCAT manuals. I mean, there's technical reports, technical manuals. API got a great series of technical manuals. And then I look at my bookshelves. Oh, over there, look at my bookshelves. I got how many bookcases? 6, 7, 8 bookcases that have conference proceedings, reports on them. Dozens and dozens. I mean, there is so much material out there, literally thousands of pages of text. So who's going to read all this stuff? Well, actually, nobody does. I sort of made a comment to Greg DeMarco a year or so ago about this, and he said, but the value of these, particularly the things like the IPCA documents, is that they're a consensus. They have brought together knowledge and information from many sources, from many people, from many spills, and they're an agreed set of guidance documents. And this is their value, is that they are a collection of experiences. But how do we use them? And that's the trick. We've just done a project for Canada, for MPRI, the multi-industry research study, to develop a decision support tool that takes a lot of this data and synthesizes it into what we call the feasibility component and the consequences of treatment methods that are applicable for oil type, shoreline type in particular. The feasibility is really an empirical evaluation, but it's based, it converts all of this knowledge, this experience into a database. And once that's done, the decision support is provided through looking at what are the concerns, what are the trade-offs associated with those options that are feasible for a particular scenario. Oh, this is scary. This is what you got to do. We've got 5 oil types, 22 shoreline types, 15 treatment methods, and we've got a matrix for each oil type, surface and subsurface. The feasible methods are identified here with green is feasible and the yellow is for small amounts of oil, little caveat there. But importantly, so you can pull this out, and we took these from existing manuals, but we don't give reasons in the manuals, or we do, in text after page after page after page after page. So what we've tried to do is to take those and simplify them into 5 different categories, which explain why a particular method is not feasible. I've sort of basically just said it, but these the categories that we look at are environmental, operational, and safety reasons why a particular method doesn't work for a particular shoreline type or a particular oil type, or for surface or subsurface oil. So, I mean, very simply, we want to present this to a non-technical user, the decision maker, or a planner, or even the public, so they can understand why a decision was made and what are the potential consequences if there are more than one option that's feasible. And we look at these consequences in terms of how much effort does it take. I mean, when you look, we're looking at Canada very often, and I mean, 99% of the coast of Canada is unpopulated. And so the infrastructure is critical. Logistics support is critical. Manpower is critical. The volume of waste generated is critical. So these are the trade-offs we need to consider when we're looking at multiple treatment options on a shoreline. We also want to look at what are the potential effects of the treatment on that system. And how long does it take to complete it? Because manual is typically slow, mechanical treatment can be much more rapid. So these are consequences. These are the explanations that we need to provide to support the recommendation to use a particular shoreline treatment type. So what do we do on shorelines? To go back to my original questions. What do we, well, you know what we do most of the time, we pick it up and we take it away. I mean, that's really simple. Or we wash it off. So really, it's not that hard. Operationally, it's really quite simple. It's the decision process that is the hard part, particularly when you want to get to non-standard techniques like mixing or in situ treatment or bioremediation or surface washing. Even then, it shouldn't be that hard. So why does it become seemingly something simple becomes complex? Well, there's two answers really. One is that because the shoreline programs go on for a lot longer than the marine side, so we're there for a lot longer, and that just gives an opportunity for more people to get involved, more of the public, of stakeholders become involved. Anne Hayward made a great point on this, particularly on Sarandang Ayu, where we were so integrated with the community. They were actually sort of didn't want us to leave at the end. But importantly, it becomes complex because the local people do get involved, and this is their land, this is their home, this is where they live, this is where they socialize. And we get a bunch of operations people showing up. It's not just the cleanup. You know, they're filling all of the restaurants, they're taking all the stuff out of the grocery stores, they're going to their favorite bars. The disruption of bringing in a large or even a small workforce in a small community is tremendous on the local people. And so it becomes more complex because it's now involving more like communications, outreach programs, understanding local needs and understanding local sensitivities. So where are we now? Well, I think we're in reasonably good shape in a sense. We've done a lot of science due to lab and field work and work on spills itself. So we understand mostly about shoreline treatment. There's a couple of areas we're a bit weak on still. I think particularly the consequences of flushing, like where does the oil go? What do washing and mixing and flushing do? When we start mixing sediments, particularly the fine grains, the colloids, clays, or sands, I mean, at what point are we creating an aggregate or a agglomerate that floats and therefore can be naturally weathered and biodegraded? Or at what point do we create something that starts to sink? And we don't know enough about that yet. This is another nice study done by Boglianco and Tansel, was looking at macroscopic, the aggregates and the agglomerates versus the microscopic oil clay or oil colloidal particles. Basically, the microscopic ones float. They're a floating emulsion, where the macroscopic typically are ones that settle quickly. In other words, they may sink. So this is an area that does need to go. I talked about the decision process. One of the things that we're trying to do, we're trying to make it easier for everybody. We have a tremendous amount of knowledge. We need to be able to pass that on to the non-technical decision makers, to the public, to the operations. Condensing this huge volume of information, and retaining the science, retaining the sound science that underpins the reasons for making a choice and the reasons for making a trade-off. So there's still things to be done. I just throw this up as a parting shot. I say I came to North America, and with 10 days later, I was up in the Arctic, and I've managed to. I didn't manage to avoid oil spills, but I did manage to keep going back to the Arctic, and that still remains one of the many of the highlights of what I've been able to do. Fortunately, have been in the north, and didn't get there these last 2 years, but I'd like to go back soon, and to go back to the Arrow, and to go back to the Matula, and to go back to BIOS to look at those long-term persistent oils. Well, thank you for. I think somebody's still out there. Tim?
I'm here.
Good.
Ed, hey, that was fantastic, and you hit it just what I wanted. So that was really what we were after. So thank you so much. And I know it takes time to put something like this together, and I really appreciate it. So we're getting some questions. As they, so feel free to, go to the Q&A and ask questions. But to get things started, let me just say, it struck me that you're a little bit less experienced than Al Allen, because you didn't start in 1970, and Al was on the Santa Barbara spill in 1969. And Lynn and I really need to keep track of. I'm between you, Al, and Hayward, and Steve Lehman. I think we're approaching kind of 200 years of experience, which is what we're after. But Al has a little bit more experience than you.
Yeah.
So remember,
I haven't retired yet, though. Al says he's retired, but
well, I'm not sure he's.
I don't think any of us retire.
Yeah, but what struck me is that's so interesting is that, like, in the 70s, 69 and 70, both of you guys were it was kind of serendipity that you got in the oil spill business, right? And that's what's interesting is, I mean, I look at this oil spill history data, and it really starts around 1970, right? And you look at decade by decade. And so when it starts in the 70s, you come to the 2000s, 2010s, there's been like an exponential decrease in the number of oil spills. So I can't imagine the 60s were devoid of oil spills, right? But there weren't people who were in the oil spill business, and they had to go grab somebody who was in, as postdoc or in graduate school to come out and do that. And why it seems like oil spills must have been a big issue, or was there just a different perception in the 60s about just an oil spill? I mean, you're talking about leaky keys with no radar on them. I imagine, at night they probably one or two hit the shoreline, every couple months.
Yeah,
or even more often than that. So it seems like there should have been this really infrastructure of people that were already in place from the 50s and 60s, because oil spills are a mess. What do you think about? What's the difference? Why did Al have to come out of what he was doing as a physicist, and you have to come out of what you were doing in the Arctic?
Yeah. Well, it's a good question, and the world changed. I mean, late 60s, we had the first VLCCs, the very large crude carriers, super tankers they were called.
Yeah.
Torrey Canyon. When that stopped in the English Channel, I mean, there was more oil spilled than probably had been spilled from one vessel than had been spilled from the previous 100 or 200 spills, and so the magnitude happened. Santa Barbara was a magnitude in a very sensitive area. Not too many years earlier, there's a book called The Silent Spring, written by Rachel Carson, which was like one of the first environmental books. It said, look at what we're doing to the planet. Look what we're doing environmentally. Until then, people really didn't have an awareness. And the awareness, oil spills being the drama that they present of a ship on a rock and oiled birds. I mean, we all know those types of media images. Those project something more than, say, pesticides, which are insidious, or it's the drama of an oil spill that brought people's attention to the fore. And EPA formed in 1970, Environment Canada 1971. Now, that's when things started to turn around. Plus, we had all these big ships that no one knew how to drive properly. Because we had not only Torrey Canyon, and you go to Amoco, Cadiz, a whole series of super tankers that ran ashore or broke it up at sea. And in the early 70s, there was, I can't remember the numbers, but if you look at the ITOP, number of casualties, it was very high in the 70s and gradually, or dramatically decreased to the present. So now we don't have that many, and it's switched from tankers now. Most of the spills are non-tank vessels or merchant vessels of one sort or another.
Yeah. That's the other thing I was going to ask you. It seems so. Yeah, you've been doing this for a long time, and if this information I have on the history of spills is accurate, you shouldn't be as busy as you were when you first started in the business. Is that? Have you noticed that? I mean, is there less call, or I mean, I know you have more call because everybody wants Ed Owens to come clean up their beach, and so you go out on almost everything. But have you actually noticed that from the what you started in 76 or so and till now, it's just the sheer number of incidents, something that's visible to you and your business?
Well, it hasn't decreased in part because inland spills have become more of a focus as well. And the last spill I did was in Walnut Creek just last year, pipeline spill with a dog team. And I think maybe the last 6 or 7 spills I've been on have all been inland related to pipeline releases. So before, again, there was not much of an awareness, but people all of a sudden, almost sort of at the same time as the Dilbit issue started to emerge, then pipelines became of greater interest. And so there's a lot more work being done on planning, preparation, and also in response to the pipeline spills than there was before. So it's changed a little bit. The super tankers, I can't remember when the last super tanker accident was, not recently. I mean, the one down in Mauritius was a cargo vessel again. So there's been a shift in the sort of the profile of oil spills, if you like.
Okay. Hey, so I got you. Let me ask you one more question, and I'll go to the questions that are so we're getting some questions in. But you mentioned about this real-time drone video interpretation. And what is that? You need eyeballs? Are you talking about somebody just needs to be watching the feed coming down from the drone and interpreting it as quickly as they can as that feed comes? Are you looking at some kind of algorithm to do it automatically, so human eyeballs don't get stressed out as much as they might be, or is it a combination? What do you recommend?
Well, we just started a project which I'm going to talk about at Clean Gulf that looks at imagery, and the first phase is going to be the visual job aids to help interpret what is there, and particularly false positives. I mean, Gulf of Mexico's got like such a range of false positives. Those have to be filtered out first. And how far can we go along the road so that ultimately we're using, and I hate the word artificial intelligence, using some intelligent image analysis system to do that first cut. What we need to do is just have a system that just goes through and says, these are all potential images, look at this one. There's the problem with aerial imagery on shorelines. I mean, on water, you've got one backdrop, it's water, it's pretty much the same color. The trouble with shorelines is you can have multicolored shorelines. You can have gray pebbles, white pebbles, black pebbles. You've got yellow sand, green sand, blue, not blue sand. But the colors are really complicated, and there are many false positives, whether they're rack or shadows, all sorts of things. I don't know if artificially we'll be able to do that triage properly. But if we can identify potential image, whether they're false or true, then the human can then look at that based on experience and job aids, observer handbooks, can do a job more quickly than can do at the present time. I don't see a short-term solution to it, but I do see a short-term job aid that can help us get there more quickly.
Well, what you're saying is a drone might take 5 minutes of video of the same beach. You don't need to look, you only need to look at a few frames of that, right? Individual frames.
Right.
So that's one way to.
Yeah, because we look at a drone is for first recon bulk oil. If you're starting to look for little pieces, you'll never see them properly. So if you make your mission objective the bulk oil identification, then to me that's a really good use. You can look at for staging areas, but that's a whole different thing if operations use it from a logistics viewpoint. But for the oil, just get those large chunks of the big black oil quickly. Get them out of there.
Okay. All right. We're almost at 15 after the hour. So let me just say a couple things and then I'll go to the questions. So next month, I'm looking at my calendar, it's November 7th. We're going to try something a little bit different. We're going to have a roundtable discussion and all the 4 speakers who started us off on this webinar series have agreed. Hopefully they'll be happy that they made that decision after it's over with, but we'll see how it goes. But we're going to have a roundtable discussion where we're going to get Ed and Steve and Ann Hayward and Al to sit around the virtual roundtable and tell us kind of war stories with a message beyond what they've already told us in these talks. So I'm really looking forward to that. I'm gonna try to MC that as well as I can, and we'll see how that goes, and maybe that'll be something that we continue to do as we move into the forward. So stay tuned for that. It'll be same time on December 7th. So with that, we're getting some questions here, Ed. So let me go through the questions. The first question is, Ed, as always, this is from Al Allen. If another spill, he says, as always, great presentation, by the way. If another spill comparable to the Deepwater Horizon took place in the Gulf of Mexico, what would you suggest are the key lessons we should take forward, including offshore operations, in order to minimize shoreline impacts and improve shoreline protection and cleanup?
Hello, Al. As we know, no 2 spills are the same, and I think we have to be prepared for a spill in which the Mississippi River doesn't protect the shoreline as dramatically as it did in 2010. I mean, the small amount of oiled shoreline is attributable to the plumes, the freshwater plumes, the density fronts that kept the oil away, except for a few areas like Bay Jimmy, and then up and around less protection afforded up in Mississippi, Alabama, Florida. I think we have to be prepared for more oil to come ashore more quickly, because it's not going to be in the same place next time. I mean, Ishtok is an example of a Gulf of Mexico spill that oiled the shoreline all the way up from Bay of Campeche right up into Texas until it hit a density front off the Galveston area and stopped. I think we should be thinking more along the lines of an Ishtok, if it's a blowout, that is, of an Ishtok situation rather than a deep water situation.
Okay, great. Next question, Ed, can you provide a few examples of when you would want to use a fixed wing UAV versus a chopper style UAV? What is the difference between the data and how you interpret it?
The data is no different. To answer the second part first, the image capturing systems are the same on a fixed wing or a rotary wing. One of those that was in the picture is actually a hybrid. It uses 4 rotors to lift and then goes into a glide mode with very, just a sort of a small, what I call a rubber band motor, very low energy requirement. The thing is, they can stay aloft for so much longer, literally hours upon hours. So you can get continuous coverage, or if you are allowed to go beyond line of sight, you can get much more shoreline coverage geographically. The thing about the quadcopters is that right now their range, but their time aloft is short, and they've got to be within line of sight. So but we've in the Chevron studies, we used fixed wings probably about half the time, flying at, you know, a couple of thousand feet with good imagery. The thing about the quads is they can go in low and slow, and you can almost land them, and you know, just get that real close up, which is much harder to achieve with a fixed wing.
Okay, great. All right, next question. Should the SCAT operation liaison be a SCAT person or an operations person? From experience, I recognize the importance of this position.
Well, somebody has to know both sides of the coin here. The Deepwater Horizon was populated almost entirely at the beginning by OSRL out of the UK, people who are used to operations, familiar with operations, and also had some SCAT training. So that was a sort of an ideal combination. Yeah, I don't think there's any one. I guess experience is the key thing. I mean, it's not a job you hand off to the person who came in last through the door. It's actually on a smaller spill, it would be the SCAT team lead who plays that role. We only really need SCAT ops liaison when the scale gets to the point where the SCAT team leads are not able to service the operations because either they're working in a different geographic area, or because the operations scale is much larger than the SCAT operation. There's just too many people out there. But it should ideally be a SCAT trained person as a SCAT ops liaison, because the connection is really with the environmental unit and the advisors, the people that write the STRs and the good practice guidelines and the constraints. That's really the driver, is to get messages from the EU into the field through the SCAT process. So I guess the right answer is it's a SCAT person rather than an operations person.
Okay, great. All right, one more question. The NOAA SOS forms are great, but a bit much for using in UAS SCAT ops. Do you have any examples for shorter forms?
Right. We, as part of the work we were doing with Chevron, we developed a shoreline oiling aerial reconnaissance form, which is it's the same as a SCAT form. It's completely compatible with the SOS form, but it is just shorter, and it just highlights the key data, which are really, you know, the substrate material, the length, the width, and the distribution. I mean, if you can get that off a UAS image or even a video image of any sort, that key data is what we need, and it's compatible with the SOS forms that we always use.
Okay. Hey, let me ask you one more question, and we'll see if we get another question up here. But I was thinking, when looking at your case studies, right, you have, you know, when you're in remote locations, kind of regardless of spill size maybe, but you're really doing things to allow Mother Nature to deal with the spill, right? You can't collect a lot of sediments and dispose of them.
Right.
And the same thing happens as regardless of where you are, as spills grow in size, and that's consistent. I spend my time with offshore response considerations, and most spills are small and they're very amenable to mechanical recovery, and booms can do the job if they're small and in the right location, right, where we have equipment and stockpiles. And so it's easy to advocate for booms and skimmers. It's more challenging to advocate for natural attenuation and letting Mother Nature do the job, because there's just physically impossible to do it when you're in a remote location. And that's the same thing when you're offshore as onshore, right? That just the resources to pick up and deal with things is not there. And the speed offshore, you got a bigger speed challenge as well. So you got to start making people understand that these kind of brute force methods are not going to do it, right? And you're either going to leave the oil in place for a longer period of time where it can cause more impacts, or you're not going to do a very, very efficient job. So the challenge that we have, I spend half my time almost, it seems, kind of advocating for these things that to me become kind of common sense, but it's not, right? And especially when you have a big spill and you get people who really mean well but have no experience with oil spills trying to help with decision making, right? And so it's kind of a training effort, right? And we try to train people in and let them know these kind of basic facts before the spill happens, but you're never going to get, you know, the right person or all the people. And so it's quite challenging. How do you see us being as efficient as we can, relaying these kind of basic bits of information that you're not going to, you know, Salundang IU, you're not going to pick the oil up and carry it to some landfill or some treatment place, and that you've got to rely on Mother Nature. So there's this kind of as needed training when people come on and try to tell you how to do things when they have no experience, and then there's the kind of during peacetime training, which is quite challenging, but we do the best we can. What do you think about these kind of advocacy messages?
Yeah, I wish I had an easy answer for you. Oh, my phone, turn it off. Wish I had an easy answer. The in situ treatment, I mean, I go back to the Svalbard field trials. We collected a tremendous amount of top quality data. I mean, Ken Lee was out there doing the sampling for the toxicity and measuring the suspended loads in the water. We've got the data. We need to use that good science under controlled experimental conditions to explain to people better. And we haven't done a good job of that. I mean, Roger Prince said a few months ago, you know, one of the best dispersant data sets is from BIOS, 1980. You know, the reason I brought this Svalbard up and the BIOS up is these are two tremendous experiments that are a wealth of data, a wealth of knowledge. They were both designed to give us that scientific foundation to answer the questions about natural attenuation versus treatment. So we've done it once. I mean, do we have to do it again? Probably yes. You know, well, the dispersant issue hasn't gone away. Bulldozing oiled sediments into the water is visually, you know, you have to get over that image of the big yellow machines just putting oil in the water. The science is good. And we try to explain it. I don't know. Maybe we need to get a media consultant who can, an influencer of some sort, who can take what we know and what we take for granted and present it in a manner, as Anne Hayward said, you know, you have to look from the other side. You need to put yourself in the place of the person that's asking, why are you doing this? So it's hard for us, I think, to make that switch over.
Yeah, you know, Chris Reddy had this idea a few years ago that we need to have a psychologist in the incident command who understands kind of how these messages are actually embraced, and maybe help us to deliver messages in the correct way. That, you know, it gives me it's one of the things, you know, I sit on the Clean Gulf committee for sessions, and you know, maybe we need to have the BIOS and Svalbard and Aerospill, you know, you're talking about all these papers. We need to get somebody to come back and re-present those, because they turn into, oh, that was done 40 years ago, that was 50 years ago. The science was no good back then, right? We can't rely on anything. That's just not true. But they really are escaping memory, and it would be interesting to put them kind of back in the new record books and get them in the proceedings of IOSC or a conference now, and just have somebody go back and pull those presentations and read some of the addition, right? Sometimes those presentations from those kinds of spills happen a year or two after the spill, and a lot of additional work is done, and pulls some summaries together. The tropic study, they've been doing a good job of presenting it as they go back and bringing up the information that was learned in previous evaluations and surveys of the site. Maybe we need a session to look back at the seminal studies that you just mentioned, and let's have a session that just brings describes the nuts and bolts of what happened and what was learned from those studies. Because I can tell you, we're not going to do very many of those studies, and we haven't done a whole lot, but it's getting more and more challenging
I mean, Ken Lee can tell you right now how challenging it is to put oil in the water anywhere in the planet on purpose, right? That's the thing.
Well, we did, back in 2015, we had a long-term persistence workshop in Black Duck Cove because you can drive there and you can walk to those asphalt pavements that are still there. And I mean, I recommend that. I mean, visits to Black Duck Cove and we had a day of Ken was presenting, Roger was presenting, others were presenting about long-term persistence of stranded oil from different case studies, including the Arrow. And then we went and walked down onto the asphalt pavements and we dug around, and Pat Lambert from Environment Canada collected some samples, had them analyzed, and that's been published. So there is a lab. I mean, to me, the best lab is, getting out on the beaches.
Yeah, maybe we can do something with virtual presentations at that to get as many people as possible.
I know it's a long way away, but the Punta Spora marshes down in Tierra del Fuego, I mean, they're mud flats as well. There's mobile oil still sitting in those mud flats.
Yeah.
I mean, the last guy down there was Eric Gunlack, I think, 2015 or something like that. And he's looking at the plots that Jenny Baker put out there in 1993. This place is ripe for data collection. And again, you can drive to it. Of course, you have to get to southern Chile first, but when you
maybe we should do that in this knowledge transfer. That's knowledge transfer. What happened at Baffin Bay? What happened at Svalbard? What happened down there? What happened at the Arrow spill? And maybe I'll talk to you, and you can tell me who the people with the most experience on those, and Paul and certainly the tropic study. And let's spend 6 weeks going back through those old studies, the Nobi burn experiments, and let's spend a few weeks going through these old studies and make sure people are at least aware of them, but give them kind of the information to learn from those.
I agree. I mean, I think case studies are what they are. They're the learning experiences, but they're not usually written up as learning experiences.
Yeah, but I think I think there's people who were actually there at the beginning on a lot of these things and can tell us, what they have learned. So I need to think about that and put that down on my list. All right, I got a couple more questions and then I'll let you go and everybody go. Looks like we got quite a few people still hanging in there. So here's the next question. Have your studies brought you to the Great Lakes, and how are the lakes different than the oceans for SCAT?
Not really any different. Any lake, I mean, they're no different from an area with a very low tidal range, like Gulf of Mexico, other parts. You've got seiches, which are, not as regular as the tides. You do get up in Lake Superior, you've got storm berms that are meters above the high water mark. They're really not a lot different. They're just a microtidal environment. We use the same forms, except for we use the microtidal shoreline oiling summary forms. Great Lakes are not any different. Rivers are not any different either. I mean, it's just a matter of tweaking to make sure that you've got the right environmental background data collected. But oil behavior is the same.
Okay, great. Here's the next question. With 50 years of learning and long-term data on shoreline spill locations, is the trend toward leaving the oil alone and letting nature take its course? First part. Second part, also, are you sometimes forced to do removal purely for political reasons?
Second question, yes. We still have to have, our job is, and Steve Lehman said this, our job is to provide sound science. That's what NOAA scientific sport coordinators do. Their recommendations are based on the science. If somebody, for whatever reason, chooses to take an action, to do some intervention for other reasons, that's understandable. I mean, there are social reasons. People who live in an area that's been affected by a spill, small communities, there are reasons other than environmental or ecological reasons for treating oil. Is the trend to leave it more alone? I think in remote areas, yes. In populated areas, I think the trend is to take even more away. You know, the problem down in Southern California right now is the background seep oil that's on all of the beaches that are affected by the pipeline break. I mean, there's probably more oil there from the natural seeps than was spilled from that pipeline break. That's a bit of science that needs to be injected. We had that problem in Gulf of Mexico, background oiling. People are more tolerant of the background oiling than they are of oiling coming ashore.
All right. All right. One more question. How are we on time here? All right. One more question. If time allows, what do you think is the best way for exciting young folks to move into this field of oil spill technology, prevention, and response?
What is the best way to get in? Or somehow go on a spill. That's where the rubber meets the road. I mean, we can teach, we can prepare, we can train, we can read books after books after books and manuals after manuals after manuals, but the rubber hits the road on a spill. If you can find a way to get involved on an oil spill, that is your primary learning process. Like that, as I say, my first spill, got on a plane, didn't know anything about oil. Next spill comes along, oh, he knows something about oil. Well, only because nobody else knew anything about oil on shorelines, and that is the progression. It's good to have another skill set. Like, I'm a beach guy. I worked on sediments and beach changes and beach dynamics. Having a skill set that you can bring to the table gets you, you know, as part of a team. Whether it's a biologist, a geologist, toxicologist, ops technical, you know, burn specialist, dispersant specialist, doesn't matter. But you know, you need a skill set to bring to the table, and then you need to spend time on spills.
Yep. Yeah, I was going to say the same thing. I mean, there's the kind of get overeducated way of the way I did it, right? Go to grad school, but you can find the researchers that are doing, you know, publishing papers, and then go work for them and get an advanced degree in the right area. Or you can go send your resume to you, Ed, or go work for ITOP. I tell people that if you really want to get on an oil spill, go work for ITOP.
Yeah.
And you are going to get on oil spill, and to a lesser extent OSRL and MSRC. But I imagine the ITOP people go out and have more experience on spills and have to learn, you know, because every spill's different, and they're going to places that are even more remote than Silindang, right? And the spill, and they have to learn and figure things out, and that's a great way to get experience very quickly. But you're right, you got to go out and work for the right people and get that experience. But there's also the right, you know, there's also the go work for the right academics who are doing work to get a foundation for that. And then there's also several oil spill schools, right, that I think people should take advantage of, those that are publicly available. Right. Al, you see, I promoted you up to speaker, and I think that's going to be any previous speaker will get promoted up to speaker from now on, especially when we start answering these questions. So if there's anything you want to ask Ed directly, Al, I think your microphone should be working.
Testing 1, 2, 3. Can you hear me?
Hear you.
Oh, great. No visual though, right?
No, I see your face. Yeah, I see your pretty face.
Yeah, you look pretty good.
Yeah, you did.
I wouldn't change it.
Don't make it any bigger or closer up.
No, I won't. Hey, Ed, as always, you're just a living treasure, and I know you don't like me to say those things, but I just have to. It's such an honor to be in this business with you. Hey, I do have one additional thing I wanted to add, and that is, you know, you're absolutely right. I think the best way to excite some of our youth to get into this field is to somehow encourage them to get out on spills and actually see the impact, and to see the opportunities for research, for maybe working on development of new techniques and equipment. That's such a good answer. I also felt, though, that the work I've done over the decades of going to the schools has really been a factor that's excited youth. And I get the feedback, not just from the kids themselves, but from the teachers. After I've given a talk at a school, or when I used to work quite a bit in Alaska, going out to the villages and visiting not only with the elders in the evenings, but going to the schools. The feedback from the teachers days later, weeks later, was that they were showing a really keen interest in learning more about how they could contribute to protecting the environment and understanding and respecting the environment more. So I would just add that to your already very good answer.
Yeah, I know a few years back, OSRL had a summer intern program. Dave Salt started that. I don't know if they still do it, but I mean, there's a summer program that lasts whatever, some weeks or maybe a month or two, you know, get hands on. I mean, you know, get your hands dirty, looking at equipment and talking to people that it's their day job. Would, you know, if they still have that sort of program, would be great. Or the Texas Oil Spill Control School, I think is maybe one you're referring to, Al.
Mm-hmm.
Yeah.
Yes.
Well, and I know OMSET last summer had a summer intern as well, just one, but there, you know, so there are those kinds of opportunities. You gotta know who to ask.
Yeah.
Heard about OSRL. I haven't heard about summer interns, but so there are some opportunities like that. Well, listen, we're keeping people from going to the ITAC meeting, perhaps, because that's where I'm going to go after this. But again, thanks, Ed. That was a great talk. You always do a very good job. I appreciate it, and I really appreciate. I know it takes effort to put these things together, and so thank you very much for doing that. And we will all of us, well, the three of us at least, will be, and Lynn, be together a month or so from now for this roundtable. I'll see how it goes. So I'm going to sign off. But thanks again, guys.
Thanks, Tim. Take care, everybody.